Now we are jumping to example number 3, right? We are given the differential equation. How do you see the differential equation? dy over dx, right? We need to find here, we don't determine the general solution, we determine the particular solution. You know why? Because we are given the conditions, right? We are given the conditions, which is y is equals to 1 and x is equals to 0. So these are the conditions that we need to use to determine the particular solution. The first 2 examples, we use them to determine the general solutions, right? Those are general solutions because the value of c, which are our constants, could be anything. So that's why I showed you at the beginning that when we have a solution that has c, we have family of curves, we have family of what? We have family of functions. We can determine many different functions using having that c. So here we're going to get exact solution, not general. You're gonna get particular solution. Now we're still gonna do the very same techniques that we used. We're still gonna do the very same approaches that we did, but we need to understand first that are we gonna be able to separate these variables? If we cannot separate them, that means we need to try other techniques. But obvious, here we are only talking about the separable variable. So don't be stereotypic and say all the times they're going to tell you in exam, here use separable variable, here use homogeneous, here use linear, here use Bernoulli. It won't work like that. You're supposed to know which technique to use, okay? So let's act as if we don't know whether we're going to use separable or not. But having a look at this equation, what we're going to try to do is we're going to try to write it in a standard form first, the dy over dx, right? So look at the equation. So I'm going to transpose, look at this side, right? We have equal sign there. I'm going to, because it's -3, I'm going to take it on the other side of the equation. However you want to do it, but I think that like this is the simpler way. So I'm going to have +3 dy dx is going to be equals to, this side I have x, right? I'm going to leave it this side, and then I'm going to take everything to the other side of the equation. Now I will be having -1 over e to the power of x, and then I'll be having -2. There is nothing special that I did. I just rearranged everything. That is all. But the aim is to rewrite this equation in a form of dy over dx. So I'm going to have to get rid of this 3. So that means I'm going to have to divide the whole equation by 3. So that means here I'm going to have dy dx is equals to, when I divide this side by 3, I'm going to have x over 3 subtract 1 over 3e to the power of x subtract 2 over 3. Now, have a look at this equation. It is still the same as that equation, just that we rearranged everything. And then, as a mathematician, after arriving at this step, you check which technique of integration am I going to be eligible to use. Having a look at this, we can use separable, we can use variable separable. But how? Remember I said everything, take it as if it is divided by 1. We cross multiply. You're going to say 1 multiplied by dy.
Before we continue, so what happens if I actually there's like the x minus 3, I divided by that from the thingy and not moved the 3 to the side.
Or it
The
is still
3.
fine. The thing is, sometimes when we deal with the equations, we love having dy over the x on the left-hand side. It's fine. You can just divide by x minus 3. It is still fine. It really does not matter.
Okay.
No. Be careful. Be careful. I realize something. -3, it is multiplied to this. This is just a term standing alone. Or wonder if there was a bracket like this, then we were going to divide by x minus 3.
Oh, -3 is it goes with dy over dx.
100%.
Oh, okay. So if there was a brackets, I was gonna be able. Oh, okay, yeah, I see.
Yes. Oh, you see, we can make mistakes like that. I love that you managed to see that because it's one of the mistakes that we can all do. So let's just be careful about that. So now,
Okay.
all right, thank you. Therefore, dy multiplied by 1 is going to be dy is equals to the whole thing multiplied by dx is going to be the whole thing, right? It's going to be the whole thing multiplied by dx. Ah, the variables are now separated. Ah, man, then we integrate. Then we integrate. We are happy arriving to this stage. Then we integrate both sides, right? Integrating both sides, what is the integral of dy? It's going to be y. We reverse, we bring in back y, right? Is equals to, here we have the integral. I'm going to take 1/3 as my constant, right? Integral of x dx. And then here I'm going to take 1/3 again as my constant, but be careful. We have 1/3 e to the power of x. So I'm going to have 1/3 there. Integral of 1/e to the power of x dx. And therefore, on this side, it's a constant by itself, which is going to be 2/3. Then I'm going to have 1 dx over there. Excuse my writing. And therefore, here we have y is equals to, what is the integral of x? We know that it's going to be 1/2 x squared, right? And then that 1/2 multiplied by 1/3, it will give us 1/6, right? X squared. You can write your x squared at the top. It's fine. I love expressing my answers like this, okay? My fractions like this. And therefore here, remember, we have something that looks like this, right? Okay, let me rewrite it like this. I will integrate it later on so that you don't get confused. We have e to the power of negative x dx, and then let's integrate this one. We're going to bring x back, right? We have the negative 2/3x. And then we are not done integrating this. We'll proceed after integrating this. Therefore, we have y is equals to 1/6x squared. Now let's integrate this. So what is the integral of, again, recall, there is a rule that says, let me write the rule, okay? I know a lot of people, they forget this. I used to forget this a lot, and until I had to make it sure that I understand this. When you have, say, the integral of, what is this thing? Say e ku du, what is the integral of this? The integral of this, ne, it's going to be 1/k. You take your k, you divide by 1/k, you multiply by 1/k, and you have e to the power of k. You repeat everything as it is, plus c. Ne? So make sure that you still remember this. So be careful about that. So sometimes we are used to e to the power of x or e to the power of negative x. Sometimes it could be 2x, could be e to the power of 2x. So just know that you're going to take that 2, you're going to say 1/2 multiply, okay, applying this rule. So be careful because people tend to forget that. So now, okay, let me rewrite everything. Okay, let me rewrite everything. We have y is equals to 1/6x to the power of 2, and then integrating this, remember we have negative 1 there, né? So it's gonna be negative 1/1, negative 1/1 multiplied by y, negative 1/3 is gonna be positive 1/3 e to the power of negative x as it is, right? Minus 2/3x plus c, which is our constant. And then this is the answer, né? But it is not the final answer. But what answer is this? This is the general solution of this differential equation. But remember, we were given the conditions. Under these conditions, determine the solution of this. Now, we want to determine the particular or the exact solution to this differential equation under these conditions. So our y is equals to 1. So on the general solution, we're going to substitute y to be 1. We're going to substitute x to be 0. So we go to this equation to solve for c. So y is 1. And therefore, x is going to be 0. So here we know it's going to be 1/6 multiplied by 0. It's going to be 0 obvious. And therefore, remember, here we have e to the power of 0. E to the power of 0, or anything to the power of 0, will always be 1. And therefore, 1 multiplied by 1/3, it will be 1/3. And therefore, when you substitute 0 there, which is our x, again, it's going to be 0. Negative 2/3 plus 0 is going to be 0, and then plus c. Let's solve for C then. We transpose 1 over 3 on the other side of the equation, and then when transpose 3, it's gonna be 2 over 3. Our answer will be 2 over 3. This will be the numerical value of C. Then after solving for C, what are we going to do? We go back onto the general solution to substitute C, and therefore that will be our final answer. Therefore, y will be equals to 1 over 6 x squared plus 1 over 3 multiplied by e to the power of negative x minus 2 over 3x, and then c in this case is going to be plus 2 over 3. And therefore this will be our final answer. And then now here we have the particular solution because we now know the value of C. There we didn't know the value of C, and so it was general. It could be anything, it's general. Then here we have a particular solution because we had the specified conditions. Now again, we have this question, which is example number 4. We are given the differential equation, and then again, we are given the solutions to the differential equations. So here, what are we looking for? We are looking for a particular solution. How do you know that you are looking for a particular solution? Because we are given the conditions. So in this case, our dependent variable, which is dy, it's y, right? And then independent variable is going to be theta. So be careful again, because the variables can be changed, right? It's not always x and y, like I said at the beginning of the video, of the session. So now in this case, okay, right, fine. Remember the standard form. We want to write dy over d theta in this case. So that means we're going to have to transpose everything to the other side of the equation. So my first step will be, here I have 3 dy d theta is equals to, I transpose my sine theta on the other side of the equation, and then I get negative sine theta. Then I get rid of 3, so I'm going to have dy d theta is going to be equals to negative 1 over 3 multiplied by sine theta. Remember, it's fine, guys. I said you can write sine theta over 3. I know a lot of people, they get confused how I write this, but this is just how I write it. But it's fine if you feel confused. You can write it either way. Now, can we separate these variables? Let's see. This is the same as over 1. Take everything as over 1. We cross multiply. I'm going to say 1 multiplied by dy. And then this side, we're going to have, what's happening with my pen now? Okay, we have dy is equals to negative 1 over 3 sine theta multiplied by d theta is going to be negative 1 over 3 sine theta d theta. Now the variables are separated. Theta one side, y one side. What's the deal? Integrate. Simple. Integrate this side. We integrate that side. You know what? Let me take this one already as a constant so that we can, let's be smart on this one. You see, now we are happy. And therefore, now, what is the integral of dy? We bring back y. It's going to be y. And then here we have our constant, which is 1 over 3. But be careful. What is the, use your table. Not to avoid making mistakes, use your table, because sometimes you forget sine theta, whether it's obvious it's gonna be cos, but whether it's gonna be a positive cos or it's gonna be a negative cos. It's gonna be a negative cos, okay? So integral of sine theta is negative cos, but that negative multiplied by this negative is gonna be positive. So we're gonna have 1 over 3 cos theta plus c. This is called the general solution, but we are not looking for a general solution. We are looking for a particular solution because we are given the conditions. So we use the general solution. We're going to substitute where we see y, we have 2 over 3. 2 over 3 is equals to, where we see theta. Where we see theta, it's pi over 3, right? So we have 1 over 3 cos pi over 3 plus c. Remember, these conditions are given so that we can solve for c, right? And then what are you going to do? You're going to transpose this on the other side of the equation. On my calculator, I'm going to say 2 over 3. It's going to be negative 1 over 3. And make sure that your calculator says it is in radians. Radians, not degrees. And therefore, 1 over 3 multiplied by cos fraction theta over 3, right? Then we get 1 over 2. Therefore, my value of C will be positive 1 over 2. And then I conclude my final answer by saying, write my general solution as a particular solution now. Y is equals to 1 over 3 cos theta plus 1 over 2. Therefore, this will be the particular or the exact solution to the differential equation.